Hello to all of you from different parts of the world. Let me just start sharing my PPT and we can start from there. Give me a second. Okay, where is the shareable? Sorry guys, I seem to have lost my Zoom window. Just give me a minute. Is this window? Yeah, here it is. Share, share, share. Okay. Teams, please confirm you can see my screen.
Yeah, we're able to see your screen.
Okay. So once again, warm welcome to everyone. I'm Brijesh Karta. I work for FloTorch, which is a startup around Gen AI. We are creating enterprise tools for Gen AI, and FloTorch is a unified gateway. And we work under the auspices of Fission Lab, who is our incubating parent company. You have already gone past this activity through the three-part series. In the first part, we have taken it step by step, going up the ladder. First, talking about LLMs and why FloTorch has the model, what a FloTorch model is, and how that is more than just using an LLM, why it is the smarter way to do things. And then, so we have highlighted the
Um,
advantages for the enterprise.
Rajesh,
Yeah.
so sorry to interrupt you, but I think you're sharing the wrong screen. We can see the notes and the slides, you know, screen. You have to like go to the slides. Yeah, that works better.
All right. Oh, I think I got what you're saying. I'm sharing the wrong screen itself, right? Let me share it properly. Give me a minute.
Okay.
So used to meet that this is giving me more trouble this time. Yeah. Is it fine now?
Yeah, it seems to be working good.
Perfect. Thank you. Thank you, Alishma. So I was talking about the first step, what we were doing. We were talking about smart models, how in FloTorch, we are taking the foundational models that we use, but instead of just using that directly, we wrap it up in a smart model of our own, which is what FloTorch allows you to do, wherein we put in guardrails, we put in routing, we put in caching. All of these functionalities are now attached to the model, and not just a model but many models because we are routing, right? So essentially what ends up happening is when people are using LLM in anywhere where we use the LLMs, this wrapper that we have created, it projects itself as an LLM to all of those use cases. And we are now using a smart LLM, an LLM which internally can do routing, which internally can do caching, which internally is safe because we are using guardrails. So even if a developer goes along and just wants to use an LLM that is available to them, they're already getting a safe LLM. So we spoke in detail about those examples and use cases. And for those among you who have not attended the webinar, we'll be sharing the links to those webinars also, so that both the video as well as the PPTs will be available to you. Then last month, we had the second part of the webinar where we then spoke, my colleague AJ, we spoke about building the agentic applications using FloTorch. We focus on agents, what has been coming up in the last 2 to 3 years, where agents are now becoming the main powerhouse of Gen AI. So LLMs do the work they do the completions, they have made an entire arena of possibilities open up. But doing just the chatbot variety activity is not really that useful. Agents are the ones which now come in and are able to do an autonomous activity, decision making, and being able to utilize the LLM brain, but provide a functionality around it. Right? And we went into detail about that. We spoke about how to use a local tool, how to use MCP, and essentially how to build AI agents and use it with FloTorch. In this concluding webinar, what I will be going through is now one more step ahead. Up to the point of the agent, we're talking of a single agent doing multiple things. And when we are creating Vibe coding, we'll just create one agent and it will do 10,000 things. We'll ask you to plan everything in the world and make it happen. But when we start looking at it from a product perspective, when we start looking at it from an enterprise perspective, we want to build once, use multiple times. And anytime we talk about building once and using multiple times, we are always talking about modularization. We are talking about making things do making things do one action very well so that it can be combined in multiple ways. So agentic workflows allows us to do that. So we had LLMs, we then had agents, and now the idea is we use multi-agent flow and try to work out a workflow, try to work out an entire end-to-end activity where agents are the actors in that workflow making things happen. So we will have a quick glance over what the agentic workflows are, what are the different kinds of workflows that are available, and we will then focus on how we can create agentic workflows easily using FloTorch, and what are the different possibilities in this activity using FloTorch. Yeah. So before I go ahead, I want to speak about AI agents again. Now, this is a slide I picked up from my colleague AJ's presentation last month because it is that important, right? Agent has really become the heart of the Gen AI activity for us. Agent is allowing the LLMs to go beyond just being a brain, which is like you know kind of static. We are going ahead and making the brain do things, do actions. So the agent and the agentic workflow around agentic runtime around it allows the agent to become the hands and the legs for that brain to act. So by our acting on memories attachment to the LLM for both short-term memory as well as long-term memory in the form of RAG, by allowing tools to be acting with LLMs and creating this kind of consistency or activity of, you can keep on asking the agent again and again. It can learn itself because it has got memory. It can keep on learning and getting itself better. So all of these things as an individual agent already is doing well. And that is an important important node of our workflow activity. But now the next part comes, which is the agentic workflow. I have just put a workflow out here for those who can see it clearly. It is a more than complicated workflow that my teammate has created, but it kind of highlights the way modularization can go, where he is trying to create a normalization and a compliance check and a payment acknowledge and a product knowledge. So essentially, he's taken almost every single action in a workflow and tried to put it together into individual agents. And the agents working together in the symphony is what finally allows that final composer of the output to be putting things together and deciding based on the product, payment, policy, etc. They decide on whether something is going to be purchased or not. So this activity which happens is what you would call as an agentic workflow. But when we're talking of an agentic workflow, we should first step back and decide whether are we talking of new things. So we really are not. Even before Gen AI came into picture, workflow has been there since the Industrial Revolution. From the time we have had the assembly line, there has been a workflow. First, it was the physical workflow, which is the assembly line, the machines there, everything had to go from point to point to point, and that's how the Industrial Revolution was successful. And then we started having workflow in the compute space when we started going into silicon. And we started having robotic workflows. We started having workflows set up in BPM and all our CRM products, all our SAP product, everything. We are essentially always talking about modularizing things and then connecting them using a workflow. When we are creating paths in our solution where we are using SQS, SNS, and all of these things, essentially we are creating a flow, and that's a workflow, right? Now, there have been a lot of tools which allow you to create workflows, which also do other things, which also call APIs, which call activities. So many of you know N8N, which has been there for quite some time, where you would create a workflow and say, okay, send a mail, send an incident report, send a pager duty. And we could do all of those things. Now, that was what a workflow essentially is. It was a predefined fixed sequence. And the idea of the designer of the workflow was that this is the outcome I require, and these are the places where there could be an exception, and I need to catch it this way. The thing that makes the workflow agentic is that when we add agents as the nodes of the workflow, for the most part, if agents are part of the workflow, we are now having a node within the workflow which is not going to always work deterministically. It is not always going to decide. So you can create very, very narrowly also, you can create an agentic workflow which only does one thing and it comes out. And most of our examples typically are like that in today's time. But in principle, you can have an agent, like an orchestrator agent, for example, which can plan for itself and then decide which of the agents does it want to call, which of the agents does it want to act with. So there is this avenue opening up in agentic workflow, which yet people are not fully utilized. We are all trying to work out a way to make that happen. But there is this avenue opening up where agents, if we say, are the autonomous bodies around the brain called the LLM, which allows it to do different things. Then we are now thinking of agents as personas in themselves. And then these personas should be able to talk to other personas and share data, share information, share control, etc. And if that is going to happen, it need not be that we plan that workflow in such a precise, narrow scoped way. Currently, we are still narrow scoped. Currently, we are still in the early days of agentic workflow. If agents have been happening from last 2 or 3 years, agentic workflow really has taken wing this year. And we are all at that starting point where we can try a lot of things. But the end goal is that if you have certain agents which can do certain things, and then you have an orchestrator agent, for example, who knows about these agents, then they should be able to call the agents and control the agents as they want to. So that is what the workflow would be when it's truly agentic, in which case the tool is autonomously deciding the process sequence and not the designer, unless the designer very, very narrowly scopes it. Okay. So I will take a moment here just to ask if there are any questions around this point because it's kind of little important. We are going to be building on this point. While we will be looking at the narrow scope in the examples, etc., but this is a very important technical point that we should try to understand. Are there any questions out there, AJ, Alishba? Okay, so I shall just proceed then. So now I want to take you through the connection between these agentic flows and FloTorch. Okay. We have spoken about FloTorch, how we can use an LLM. We have spoken about FloTorch in agent. So these two webinars that were there before are very important building blocks for the workflow. Because at the end of the day, what is the workflow? The workflow is connecting agents together, which means the entire block is important. So first, we have the models that is being created by all the companies out there, OpenAI and Google and Meta and Grok, and they're all creating models out there that all of us want to use. And there are some of us who are taking those models and creating our own models, creating SLMs. So, and then there are embedding models people create. So there's a lot of model stuff happening, but on the whole, at this moment of time, we are going to many of these foundation models, chat models, etc., that we want to use. In the first webinar, we learned how those models can then be put into what we call as the FloTorch model, the smart model, where the model becomes the heart of the FloTorch model, but we add guardrails, we add routing, we add caching. So this gives the FloTorch model a certain amount of smartness, a certain amount of capability that the individual model on its own would not be able to do. Then we see that how we those FloTorch models then can be utilized by agents that we create. So we are creating agent using a FloTorch model, which means it is now deriving all the advantages that the FloTorch model has. The agent also has because it is essentially using that model. So the guardrail, the routing, the caching, all of it comes for free by the fact that we are using the FloTorch model. Agent is agent, so it has got prompts, and we have tools. So agent in the for the way we are creating FloTorch right now, at this moment of time, an agent can have MCP tools that can be created in the console, or we can use local tools in the user space when we are creating the notebook. And this has been shown in the webinar last month. Now we come to the final part of this puzzle, which is agents then become workflows. And right now, there are two kind of workflows that we are able to do in workflow in our console, which is we can create prompt chaining workflow or we can get parallel workflows. But essentially, this is the way it is coming together. Now, if you go to FloTorch, if you open up FloTorch, and we'll show you the link for FloTorch.ai. If you go there and press get started, you can just basically get started and try it. And when you see the left side, the menu of FloTorch, you will see this menu here. And if you look at the menu, every single item there are the building blocks. We have guardrails, we have tools, we have data sets, we have memory, we have knowledge bases. They build up models. The models build up agents. Agents then have workflows, right? So that is basically what the FloTorch is. FloTorch is basically helping you create, source every part of that agentic flow, put it there, and then the developers can create agents, they can create workflows on a safe environment, on a centralized environment, and on a agnostic environment. So now let's go on what different kinds of workflows can there be. Now there is, like I said, it's a new thing. Everyone has a different take on this, but our team, we really like the anthropic take on it. So this patterns that we're talking about is the patterns as showcased by Anthropic last year when they put together this idea. At that point of time, they were not even calling it agents; they were just saying it LLM patterns, but it's essentially agentic patterns now. So the first one and the most simplest one is prompt chaining, and that's the one that often is used. We often use prompt chaining for everything we do, where we will take the problem statement, break it up into tasks, and we assign an agent to do those tasks. Sometimes it is counterintuitive, like we would not think about it in the normal way of doing things, but in an agentic way, it makes sense. For example, you will write an agent which says, take a topic and write something about it. And then you will create another agent and call it a critic agent. And you will tell that agent, hey, your persona is a critic. Now read whatever has been written by this agent or whoever is sending you the information, read that information and criticize it, find faults with it and send it. And then you could create a third agent, or you could create the first agent itself, taking back this information and again making the next version of that. So, by having this kind of agents, we can have the scenario where you have things happening, things self correcting, and then changing. So, prompt chaining is one way where you can do this kind of things where you can make it go from point to point to point to point. So, one of the workflows we were working was that you take a topic, you find 10 ways to write it, create the topic, then get a feedback for it, then go and SEO optimize the topic, then take it out, right? So essentially what we would point out, so different phases of a solution or different people doing it, that basically becomes prompt chaining. So, and prompt chaining ends up happening in almost everything because any small little part where more than two agents talk, it ends up being prompt chaining anyways. Then the next one we have here is routing. Now, in routing, the way we look at it is that when the query comes in, we have a router agent. The router agent's job is not to solve the query, it's only to work out what level of what is the kind of query it is. It could be various decisions that you make on routing. Sometimes you may decide based on complexity. If the query is quite a complex query, it is asking a lot of questions and it is having words like think, reflect, and all of this in the query, then you might decide, okay, you know what, you need to go to this branch which has an agent which is a research agent, right? And it's going to call a heavy LLM. It's going to take time to come back, but the query requires that. As opposed to that, you could have the a query which is basically what is the time, what is the weather of Pune right now, right? Now that is a very frivolous query, simple query, and it'll say, you know what, just send it to Nova Micro, something like that. So send it to this agent, which is like a search agent, and it will search the internet and give you the answer, and it's as fast, quick, and there's nothing to it, right? So routing helps us do that. It can be specialized. So if a FAQ is created in your company and it's a financial question, and the financial question is asking about certain things, right? And the person who is asking is from working from a domain where he's allowed to ask those certain things, then maybe you go into a completely different pipeline, which is a confidential pipeline, where we are the agents there are specifically double checking you're the right person, then giving you the information and logging everything down or something like that. Whereas everyone else is going somewhere else, some finance or HR. They're just being split between finance, HR, resources, etc. So the routing pattern works that way. Then we have a very simple pattern, which is a parallelization pattern, that whatever we do, we split it apart, right? So even in routing, in some ways, it goes apart. But the difference is in parallelization, what happens is that what is coming from the start of the flow, or even from there might be an agent at the start also, that doesn't matter. But whatever comes, the same input goes to all the branches. And it goes to all the branches, and then those branches do the stuff, and then we aggregate it again. Now, it could happen just like in the CPU world, where this parallelization is happening because the problem is that difficult, and the first agent is splitting the problem into to 20 parts and then sending it to 20 branches, and they're doing it fast and they're coming back. So one advantage of parallelization would be speed. Sometimes it could be some other way that the same input is handled differently by the thing. So you may have an input, and one part is going to analyze, let's say, the cost impact of that data point, and another part is going to look at the time aspect of it, or maybe a CSIS aspect of it. So they may be agents working on the same input but from different angles, and they want to aggregate it later so that you, as a customer, get an output which is handling all of the different angles of the same data point. So these are the reasons, places where parallelization could be of very big help. Then we have orchestrator worker agents. Now, this is not there in FloTorch today, but by December we'll be having that, because that's a little trickier one. In the parallelization and prompt chaining that we have, to some extent, we are still talking of the narrow scope. We are still saying that things will move from here to here to here to here. So there's a deterministic way that it goes through the nodes. But when it comes to orchestrator workers, what happens is that this orchestrator is the godfather. The orchestrator decides, okay, this is the problem statement. It makes a plan saying this is how I'll solve the problem statement. Then it goes and checks, okay, these are the agents I have who can help me solve the statement. And it then tells, okay, go ahead and you go and do this, you go and do this, you go and do this. So maybe an insurance agent might say, okay, OCR, go and scan those documents. Here's some documents, scan it and send me the text. Here, when the text comes, it may go and give to another agent which says, okay, put this text into the SQL database. Then it takes it and gives it to another agent and says, analyze the risk. So the thing here is that the orchestrator becomes like this entity which is going out and sending things to the different branches and then expecting the answer to come back. That is a very main difference from what parallelization or prompt chaining would do, where it is just going into one flow. You start from here, you end here. That's it. But in orchestration, you're giving, answer comes, giving, answer comes, giving, answer comes, and then you end it. So orchestrator is basically using the other agents like tools in many ways. And that is going to be a very core kind of a workflow in the coming days. But the agentic runtime around that is not straightforward. It's always going to be tricky because of this take forward and come back kind of a thing. But it is something that is very interesting to do. So we are now attacking that problem on trying to get it done in a very efficient manner. Where can we have a registry of the agents available, and can orchestrator know about them, and can we then interact with them as required based on the auto orchestrator's decision making? So that is one important pattern. And final important pattern that we consider in line with what Anthropic has suggested is the evaluation optimizer, where one agent is evaluating something, doing something, finding something, and the other agent, based on the evaluation of what is happening, is optimizing whatever is the thing that is being evaluated. So the idea is that it is like a self-learning loop that we are creating. And that could be something that becomes very critical for us when we start creating these agentic workflows, which are supposed to run for weeks on end, months on end, right? And what happens is that a lot of the decision making is dependent on the LLMs that are being running behind it and the context that is running. So as the context changes, we will keep on training the LLMs. We have to keep on checking whether we have started hallucinating a little bit more. So all of those checks are going to potentially be done by workflows which are of this variety, of the evaluator optimizer variety. Yeah. So these are the five agents that we're talking about. When you go to FloTorch today, like I said, you can do prompt chaining and parallelization without any issue. Come December, you will be able to do orchestrator workers also. And evaluator optimizer, we have experimentation on right now. But we'll be bringing those in a little bit later based on the feedback of how people are using it and checking it out. Yeah. So I'll move on to the next one. And now it's from now on, we are going to go into a lot of the actions, a lot of the activities, right? So right now, we'll go to I'll just show you the GitHub link to Notebook here. So I'll just stop sharing my PPT. While I'm doing that, are there any questions for me? Okay, no worries. So here we have in resources, I brought you here to resources, which is our GitHub FloTorch resources. And we have here what we call as the content writer. And for some reason, we are having a very slow internet here. Let me just try this again. So you'll see the content writer here, and I have here it is. So we have a content writer agent we have created here, and you'll see a lot more examples like this. I will be sending the links to this when Alish sends out the PPTs and all. We'll also be sending all these links out to you. So in this agentic workflow, this is the most what I would call as the most basic way a workflow would work, which is that we will go ahead. So let me just go to Collab. So I've already opened it in Collab. So let me show that to you in Collab where it is a little more clearer to read. So if you see, Alishba, you can see my Collab screen, right?
Yes, I'm able to.
Okay. So over here, we do some very basic things. We install the packages, we import the libraries. As you can see, we've imported that. We've imported the FloTorch ADK. Now, FloTorch has wrapping itself on ADK, which is what we have explained last time. And the using that, so this was shown last time also as part of the agent activity. Okay. So then we give the API key for the FloTorch so that we can interact with FloTorch. And we finally create the app name, and we create two agents, topic creator and content writer. Okay. Now these two agents have been created in these two agents have been created in FloTorch. Okay, and I'll just show you that too before we move. So this is my production environment. And here, if I go to agents, if you look at builders, so I have a topic creator agent, which I created in FloTorch, which we showed you last time how to create this. And here, this agent takes a input, takes a data from a URL, PDF URL, and it tries to get somebody to call something, and then it basically runs. Okay. Similarly, we have a content writer agent, which then takes the topics that have been generated by the first agent. The first agent is reading a PDF and trying to find 5 topics. Content writer is then taking those topics and creating 2 to 3 paragraph on each topic. That is the simple idea that we are creating. Okay. So these two agents have been created here, and I am now invoking those agents in my collab. So I'm saying my topic creator agent is topic creator, content writer is content writer. This is my URL, and this is just the app name and the session. So in the session, we'll know all the traces which is going through. Okay. Now after that, I created a local function to be able to read a PDF URL. And so I'm taking a PDF URL, for example, this one, and I'm then calling this function to extract the content from it into a markdown file. Okay, that's all it's doing. Now, all of that activity we are doing is actually it may be even a JSON file we are taking, a text file. So then I've shown here how to make the agent, which I already showed you. So if you are using this, you'll be able to make the agent. And after you make all the agent, etc., this is all about how to make the agent. So after you make the agent, you come here and you start creating the client. So now you have the FloTorch ADK agent here, which is the topic creator. And in the topic creator agent, I have created the get PDF text as a custom tool, right? So I ran this like a little earlier today. And what we found is that I connected this and I created a topic creator agent instantiated. Then I created a content writer and I created a content writer agent instantiator, right? And I've initialized all of them here. Then I set up the sessions for it, and all of these things I have to do now because I need the agent to run. And these are the basically the agentic runtimes which make it run. So I set up the sessions, I set up the runners, and all of this is fine. All of this is just basically making the agents run. But where does the workflow come into play? Now, this is where what I did here, and this is why I'm calling it the most basic workflow you can create. It is a prompt chaining I'm doing, but I'm not using any other runtime to do it. I'm not using any framework to do it. I am doing it myself. I am using the ADK framework to run the agent, but inter-agent interaction I am doing in code. So over here, I'm in this function which is taking content from PDF. I am taking that message, which is basically the user prompt coming from here, like do this, and that message I am then passing to my runner one, which is for the topic creator, and I'm sending that information there, doing a single turn run to get the agent to run, do the required activity, and get a response topic creator. This is the response I get. Okay. Then I'm taking that response. This is just printing up for our purpose, which you'll see down. But the main thing I'm doing is I'm taking this response, and then this response becomes the input into the next run of the runner two. Runner two is for the content writer agent. So now content writer agent, the input for the topic creator agent was the message user prompt. For the content writer agent, the input is the response topic creator. So we literally, for want of a better word, manually took the output of the first agent and gave it to the second agent. So we have kind of mechanically created a prompt chaining in our code. So this is just to show that workflows can be created this way also. As you can see, it's going to be cumbersome very fast, and complicated workflows will be very difficult to do it this way. But if you're just interacting between two simple agents, or if you just want to pass stuff, it is as simple as taking a output from one function and giving it to another, right? So here, for example, we ran that, and if you see here, when the tool is called, where it will say, when you define the local tool and it's called, it is asking for an input, enter the PDF URL to read. So that is what happens here. At this point, it asks the enter PDF to give. I gave this URL. It said there are 10 pages found, and it then extracts the page. This is the extraction. I printed it. So this is the extraction of the PDF. Once it is extracted, then it goes ahead and it will go ahead and finish that activity. It's going and taking. See, the PDF text will get the required output. The result is all the different topics that it has found. And then from the topic that it has found, it will now go, and now it will go and give to the next agent. And the next agent will then work on it and get the final response, which is the output for each topic found. It has created a multi-line paragraph, right? And that is basically the output of the whole thing. So this is a prompt chaining which is happening, where I'm asking the first agent to do something. It is calling a tool. The tool is getting a PDF. The PDF is then being extracted. You get some topics. The topics then go to the next agent. The next agent takes each topic and creates content, and that then becomes the output. So this is prompt chaining, but this is prompt chaining happening mechanically, or manually in some ways, through our code. So this is the most basic. At this point of time, you need to know nothing else except how agents work. Okay. So this is the first part of that activity. Okay. Now, when we come to the presentation again, from here, then we are talking about runtime now. Okay. All that hard work that you did. So there are two pieces of runtime which has happened here. One has already happened, which sometimes we don't consider it as runtime at times, but it is happening. Agent running is also due to a runtime, because an LLM call is an LLM call. That's straightforward. But the LLM call, what will it do? It will give you a completion. That's all it does. You need to be able to do something based on the completion. So LLM call may say use tool. What does use tool mean? So we need to have a runtime which is orchestrating that activity for the agent to work. And that is what all these runtimes like Google ADK, Crew AI, LangGraph, LangChain, AutoGen, Strands, all of them do. They make that agent operate. They make that agent work. Similarly, Between the agents now, for the control to pass from one agent to the other, again, we need to have a runtime. So agentic runtime, when you hear, it has both these aspects to it. There is agentic runtime happening for making the agents run, and there is agentic runtime happening to make the flow between the agents run. Now, the agents running part of it is getting more and more sophisticated and is really getting very good. The between the agent part is still a work in progress, according to me. There is still a lot of gaps. We still are trying to utilize the old workflow tools at times to work with agent to make things happen, right? So, like, A2A is coming out from Google. We are trying to understand that, but there are some gaps, is what the general assumption is between the technical people, and we are trying to find out what those gaps are and resolve those. But on the whole, the runtime is the execution environment. It is the environment where all of these instances, all of these assets are actually able to operate. And the main operation activity happens because of memory state. So remember, just like all the agents have got state and memory. So by definition, the workflow has a certain amount of state and memory due to its nodes having state and memory. Similarly, tool execution, cyclical possibility, multi-agent coordination, all of this can happen, and that is because of the runtime. Now, what are the kind of runtimes that is useful for an agentic workflow to happen? So LangGraph, LangChain allows you to do those kind of connections. Autogen allows to some part. Crew AI allows you to do to some part. See? And then you have some of the older systems like Temporal is a workflow generator. Temporal, you can make any workflow run using Temporal, but you can make an agentic workflow also run. So, same way you would have seen ki N8N could be a workflow, right? You can create multiple agents in N8N and it works. So, again, N8N is having its own runtime working, which is going from node to node to node. It doesn't care if it's agentic or non-agentic. But if it is agentic, it works in a certain way, right? And when it calls agentic flow, it is internally using, in case of N8N, I believe it is internally using LangChain to be able to run the agent, right? Similarly, for example, in our case now, which is where we are going to. I don't want you to have to write agents and then decide who I will call and how I will call. So I'm going to give you an environment where you have a runtime. Now that runtime when we use, today we are using certain amount of different workflows. And for each agent, we are using ADK for probably at one point of time, or maybe we'll use Crew AI at one point of time, which is a decision we'll take because it doesn't, you're not concerned about it. You're basically saying, hey, this is my workflow, make it run, right? So that is the way you will create workflows on FloTorch. So in FloTorch, what will happen is that more and more you will be going out and you will be creating this kind of a chart, this kind of a flow, and every single blue block here is an agent, right? So we are very, very focused on agentic workflow. We are very, very focused that every node is an agent at it. We are not really doing a combination of an RPA and an agent and all of that. We have tools which do that. People are doing that very well. We are talking about enterprise agentic workflows, and so our focus is here, right? So now here, as an example, you're seeing a screenshot of e-commerce order risk evaluation workflow, right? So I'll just take a step outside the PPT again and just show you what I'm talking about. So let me look at the QA. So this is now I'm trying to show you something in my test environment. Okay, this is going to come out brand new very soon for all of you by the end of this week. So it's a very exclusive touch. I'm going to show you something. So before I show you that though, let me just show you a workflow where I've just got a workflow here. And for example, this is an article generator workflow, right? So I've got a different aspects here, like, creator, writer, creators, and end. Now, if you look at each of them, they're all agents which have been created. Each of them is a standard agent. There's the input schema, output schema, there is an LLM, there's a goal, all of it is there, right? But essentially, the end result is that we have this kind of a workflow available to us. Okay. So now I'm just trying to show you something which is, let me just run this and show you. Okay. So this is what we are calling as a blueprint. Okay, so we have something called, we are coming out with a blueprint idea. There are blueprints in many, many different idea places, but we are coming out with a blueprint idea here. And the idea is that we can create agents and flows ahead of time, and I can give that to you. So here we are doing a built-in blueprint where we have these agents, right? And we have one workflow called e-commerce order risk evaluation workflow. Now, this is in development and in testing, so please bear with me if we face some issue, but let us just do here. Okay, so if I put it into this workspace, okay, and I say validate blueprint. So we just got validated. It says, okay, all of the resources can be created. And how are we creating this? Again, is an interesting thing. These built-in blueprints are creating agents which require LLM, as you know. Now, if you go and connect to our environment right now in FloTorch.ai, and if you go to the AWS version of FloTorch.ai, we are having a deal going there where we are giving you access to AWS Bedrock models, and we have in fact have ready-made models available that you can use, FloTorch models available that you can use for a daily token ratio. You'll basically get a certain limit of tokens for a daily purposes at the organization level, and you can use those assets till those tokens are used. And on every 24 hours, it will be reset. So the idea is that just to give people an opportunity to try out these workflows and try out the tool and be able to do some functionality. And we are giving almost, if you take a Nova Micro, which can do a lot of normal stuff, you are getting almost 65 million tokens equivalent. Of course, now if you were to take a Claude 4.5, then the number of tokens that you will use up is much more because of the kind of the model it is. But essentially, it is still good enough for you to do a lot of experiments before it times out. So here now, using that advantage that I have some models already available, I'm able to deploy onto my workspace, right? So now they have validated the blueprint. They've said this is working fine. The workspace I've chosen does not have a problem. I can deploy to it, so I'll deploy to the workspace. Okay, so I'm deploying to the workspace now. It's going to my dev workspace over here, right? And if I now go to this workspace of mine, and if I go to agents and workflows, we will see a e-commerce order risk evaluation, right? Now this is the short I was showing you, and this was not there in this workspace before. Okay, that is why it was able to apply. So the whole idea was that using that blueprint, you did not have to go and create models, you did not have to go and create agents, they got created for you, right? So this is a very good way to onboard stuff. This is a very good way that your architect might decide that this is the correct way of this workflow, and then it saves it as a blueprint, and then different workspaces in your company can use that blueprint and apply it, and then if required, they can build on top of the blueprint. So everybody is not starting from zero. You're starting from some learned level, and you can move on from there, right? Similarly, we ourselves can then create built-in blueprints for industry wide. We can make some for finance activity, insurance activity, etc. That can help people start, instead of facing an empty screen. They can start with some workflow, and then they can decide this is what they want or this is not what they want, and they can make the changes required, right? When you have such a workflow, this workflow creation is essentially like I did it like with nothing at all, right? I just basically created a workflow by creating the blueprint, which will be available by the end of this week in production. But suppose I was just creating a workflow, it is still able, you can still create it in a no code way by just going into the workflow and just uh, adding agents, simple as that, right? So if I create like a, I'm just now creating arbitrarily just to show you. So I can just create this agent, and then I create another one, right? And then I connect it here. So if I do a start kind of a thing and connect it here and then connect this to this, right? I can basically create my workflow. So this is what we are saying is a no code part. So here your function expert people in your company who don't really know code much, but they understand this flow, they understand the functionality. So if you create your agents using the nouns and verbs of their domain, right? Then they know that this agent is supposed to do this. They will be able to create workflows as complex as they want, just like they used to do in the BPM and days, right? And they can connect all of that and make sure that the flow is right. So this is the idea of the no code part of it, right? Now, when you have a no code workflow like that, you want to try it out. Okay, now you've created a workflow, you want to see if it's working or not. So what we are providing is like this workflow area is also a playground. So if you come back to e-commerce, right, and you see this one, I can just check what happens when we send messages through this. To be able to do that, I will give a JSON. I know from my knowledge of looking at this preprocessor that it requires a JSON, right? So if you look at the output, there's an output schema, and that's a JSON that goes out. Okay, so it requires a JSON. We are trying to structure the output as much as possible. Input, we have not kept a JSON per se, but we understand JSONs because the LLMs understand JSONs. So what I would do is I'll say, okay, I'm going to put a JSON out here, and I'll say this is some input for it, that this is a user, this is the payment, do some analysis and tell me at the end of the day, tell me whether it will work or it will not work for me, right? And now we have started executing the workflow, and now the workflow is getting executed. Right now, I don't have any tick mark internally, but what we do have is review results over here, which shows us the session movement. Because essentially what's happening is this entire workflow is an acyclical graph, and you are basically getting a pointer to the session. And what we are then doing is we are polling the session and finding out what's happening. So all the blue parts are the inputs going, and these are the preprocessor got this output. Then the user history got this output, and the payment risk got this output, right? And then it goes out to the risk aggregator here, and the risk aggregator got this output, and it basically says approve because both of them said approve, right? And both of them had said approve, so it is approved. And then final decision says, okay, based on everything, this is the situation, we are approving it, right? So now you have tested it. You can test it right here. It's a no code way of running this code. You can see what is happening and you've tested it, which is fine, well and dandy. But then how do you put it into production, right? You have created a workflow. You want that workflow to work somewhere. It may even be an endpoint to an NA10, or you want to run it in your production code somewhere else. You need it working somewhere. So it basically, this endpoint that you get, that is the key. You're basically running a session, and at the end of the session, you're going to get some in output, and that is what you really require. So it is like sending out a method, awaiting for the response. A callback comes, you get an answer. Similar thing is what we are doing here. But as an example, again, what I will be putting up in that resources space is one more collab that I had created. So in that collab, if you go and see, which is here right now, I just ran this before our call. So it's a very simple collab. If you can see, this is the entire code. Okay, where I'm getting the base URL, I'm getting the API key, I'm getting the workflow name. Workflow name in this case would be whatever the e-commerce, whatever, right? I am giving the input, the first input. Then using the SDK, using the FloTorch SDK that we have, and using the workflow from within the FloTorch SDK, we are, and this is right now in beta. This again will be available as a production one by the end of the week. So when that works, what we end up having is we get a FloTorch workflow as an entity, and then that workflow we run, giving the input payload, and then we are just waiting for the final result. So as you can see, we have put info on, and as you can see here, the FloTorch workflow was initialized. It went on happening, then the polling sessions happened, and then finally we got our output. We said that this is a summary, the order is approved. You saw it's the same thing we got there because the same kind of input we had, right? So this is the way that is the low code now. Again, you are writing code, and typically you will write some code when you want to connect this to something. It is not like because you're writing in the console, you're setting it up in the console, doesn't mean that the code will always run in the console. Code will run where it runs. But as you can see, the code can be run very easily because if you would not be running it this way, if your code was not, if we did not have an SDK to do this activity, we would have to take care of all the session handling. This code, like we as in the user who's writing the code would have to take care of all the session handling and take care of that, which would have been a very big burden, right? So we are trying to make that easy by saying, okay, SDK will handle it, don't worry. You just give a workflow, make it run, and you'll get the final output. Yeah. So that is how workflows work. And all these workflows which work, they're all giving us logs. They're giving us observabilities. As you can see, the agent running is happening, then the chat completion is happening, which means whenever the agents run, they invariably are calling the LLMs, right? So chat completions are all the LLMs. So you are getting a clear idea on which agents are running. You're getting an idea of which providers are being called from which request model, what is the cost being incurred in that call, what is the latency, what is the overhead, right? All of this information you're getting. If you click through into it, you're getting trace information also, right? So there's a trace information happening about all the different prompts which are happening for this one call, right? Where's the routing happening? All of this. You can go into any one trace and you can start seeing what's happening there, right? So observability is also there. Logging monitoring is also there. So which means again, by using this, your company will be knowing exactly what are things being monitored, what are the actions happening. If you go to the dashboard, you'll be seeing activities going on all over the place, right? All of these activities which are going up is because of me running it right now, right? And if typically I will look at the last 45 days, which is what you normally see, you'll see all the stuff that are being running, right? So the whole idea is that you start getting that you are running your builder stuff, you are running your code, but the advantage is seen in the enterprise also that we are able to see all of those activities, right? Now, before I go away from this screen, I want to show you two things which I'll come up in the end of the presentation also. But I want to highlight what I've been talking about with respect to the provider part. Okay, so what we are doing is that if we go to the administration, which not everyone will go, if you go there, in the provider, we have something called as FloTorch AWS Bedrock Global, and you will see the scope as FloTorch. Every other scope is to the workspace, but this scope you'll see as the FloTorch. This scope is happening because the we are creating a global provider, which is the Bedrock East, which we are basically saying that this is now available to all of you to try out. You can take any model from Amazon Bedrock East one and try to use it. Okay, and the tokens will be applicable to that, right? So you're getting credits like every day we'll be getting a certain amount of credit added, right? And then that credit will expire if you don't use it. But if you use it, like I'm using it today, quite a lot of testing I've been doing for this webinar. So as you can see, these ones are the ones which are token oriented, where we are bearing the cost for it for you to try out. So all of those tokens are getting generated, input and output tokens are coming out. And I have now used like 7% of the available. So all of these things I've done, and I've only used 7% of the available, right? And we have like something more like 5.3 million more available. So that is the kind of thing that is left on that activity. And if you go to workspaces, then any workspace you go to, like this workspace, and if you go to the model registry, you will see again, you will see there are these models auto-generated chat models, right? And these chat models are the ones under the scope of FloTorch, which are available to you to try out. So the minute you log in, you don't have to do anything. That provider and this models will be available to you, right? Which means that you can immediately start trying out to write agents, writing agentic workflow, and try to make it work. And then you can start adding your models. Now that you understand how it works, then you can start adding your Gemini models and your OpenAI models and all the other ones. Yeah. I'll just take a pause here to ask if there are any open questions for me to answer. AJ or Arishpa?
Hi, British. We do have some questions in the chat. Let's do one thing. We were thinking that we can answer all of them at the end of the session. So we'll do a
Okay.
Q&A, and everybody has any question, they can put in the Q&A box and we will get them
Yeah, we
answered
are
live.
almost to the end of it then because I've shown all the activities. I've shown the low code one, I've shown the no code one, and I'll just talk about what I just spoke about it. So, what I spoke about was this one where you are getting the free environment, free tokens every daily. You can scan this, or you can just go to FloTorch.ai, click get started, and go to AWS. Remember that you need to take the AWS version because this we are doing for AWS exclusively at this point of time. The tokens are available from AWS. Okay. And the other part of the story is that even keeping the free tokens aside, if you log on to the environment today, we are not charging you for the use of the environment. If you're using the hosted environment, typically it will be charged on a subscription basis. For the enterprises, It doesn't have to be in the hosted environment. We can just take our Dockers and we can put it wherever your environment is. It could be a hosted environment, it could be your private cloud, it could be your server. Doesn't matter, we can put it there. But for people like us, builders like us who want to try out, the hosted environment is a good place to do that. And if you go to FloTorch AI and get started anywhere, AWS, if you go, you get free tokens. But if you go GCP, Azure, because you want to try it out, you go to any of those places and 1 billion token usage, right? Whatever you're bringing your keys, you have your LLMs, the tokens are being generated. As long as 1 billion tokens, which is roughly 1 million requests on the gateway, we are just giving free. We will not start subscription till then. So, in a very, very broad way, around 2 to 3 to 4 months of free usage you have to try out everything and make, work out. Okay, is this what you want to do? Right? So that is one more thing I wanted to highlight. You can scan this to be able to go there, or you can, like I said, go to FloTorch and click get started. Also, I think Alishpa and AJ would have been putting some links on the chat for you to follow. Yeah. So yes, sir. So yeah, Q&A.
If everybody has any question that hasn't been answered, since this is the last session, it could be about the previous sessions or this sessions. If you have any questions, put them in the chat, put them in the Q&A box so that Bridge can answer it for you guys.
Yeah. I can. Let me just check the Q&A box. Okay. Why the split between two inputs? Why not evaluate them linearly? Uh, Adam, I just want to see. If you're talking of the insurance one I'm talking, it is just artificial split. Yeah, it could have been done linearly also. We can tell the agent to look at one part of the solution or the other part of the solution. But we wanted to check how does parallel work? Does a parallel work properly? Will it aggregate properly? Just from that angle, it was we have tried it out. Yeah, but there are cases where that split is not that artificial. Like I said, you could have a situation you can imagine, like you're doing something and it's the same PDF available, same URL is available of the PDF, but you want some one action to do OCR, another action to do something else, maybe maybe analyze the metadata of that file or something. So you may want two agents to do something different, and you don't want it to be sequential to save on time. It is action that can happen independently. Then why not make it happen in a split? Yeah, so many times you will do splits like that also. Amir, I am. So I think the main point in Gen AI that I'm seeing, and now that I've been working on it for quite some time, is that there is no alternative to trying out things. Okay, this is one of the places I've noticed that how much our academics is very important. It's very important for you to understand, like where things can happen. It could be looking at Capathy and how things come together, or it could be looking at Ethan Mollick and saying, okay, what are the use cases in the world where you can use it, which is all fine. But if you don't get your hands dirty, you always get a little bit of a gap from what can be possible, what is not possible. Once you start getting your hand dirty, it is a slippery slope. It's a fun slippery slope. Your mind is always thinking those things. So when you're doing that, what happens is that uh, trying to work out this. So it's not so technical as much as it is like, okay, I know how to make this work. Like some of the best people in AI I know, in person in my kind of city of Pune, are people who come every Saturday, sit down for 2 hours or 3 hours in a coffee shop, and they just come up with an idea. Okay, let us make this today. Not all of them are coders, not all of them are developers. They come from different fields, but their point is okay. I don't want to code. I want the Chat GPT to tell me how to do it. I want Claude to tell me how to do it. But the idea is they have a problem in mind. And I think sometimes the best thing happens is that people like me, who are essentially a coder, we can make all these tools, but the people who use the tools are the ones who have some real problems or gaps. Like I was talking to people, can they use Hotspot? Can they use can they interact with tools that they use? Can they send out mailers? Can you get incident reports? So there's a lot of such things that can happen. And if you're going to do that in our platform, the advantage you have is that you can create this and keep on building on top of it. So you create an agent, you create a simple agent, then you create a little more complicated agent. They don't disappear; they're always there. So you start now playing with the agents. You can have a combination of agents. You can try workflow in this way, workflow in that way. You can go ahead and experiment with them. We have an experimentation module which allows you to do experimentation in parallel. So you can decide this LLM I want to try out my FloTorch LLM, but I want to see for this prompt, this ground truth, which foundation LLM is good. You can do for 5 to 6 LLMs in one go. Do a raga, get back. Very soon, in somewhere around the mid of December, I will give you SDK, which allows you to do agentic evaluation. So you will run an agentic thing, and then you will evaluate it, saying, is it working properly or not? So all of this will happen that you don't have to write code for everything. Many of this will be push button, or many of it going to be low code. So the point is your focus will be on trying to find the domain solution rather than have to wrestle with code. Yeah. I hope that helps, Amir. But do get in touch with me on LinkedIn, or get in touch with me anywhere you see, and we can continue to have some of these, activities, because I'm very happy to always try and get use cases together and try to get that working. Yeah. Yeah, Nathan, I believe we'll have the recording in both YouTube, and even Alishba will be sending us the link after the call by tomorrow, I think. Yes, Shankar, in the agentic webinar, if you see, okay, what you will notice is that the agent, we have got created a FloTorch. You know what? I'll just show you in 1 second. Yeah. Let me just share again, and I'll show you something. Okay, so let me get out of this. And yeah, so if you look at this model right now, okay, now you have the agent. Like, let me go to the agent. Can you all see my screen? Alish, they can see my screen?
Yeah, your screen is visible.
Yeah. So here now I've created a preprocessor agent. Okay. All of this jing bang is there. Now, if you go here and see, this agent can be utilized it can be written in code using my FloTorch ADK. I'm saying FloTorch ADK, but basically it's FloTorch. You can just download FloTorch, right? Using my FloTorch SDK, we are wrapping around the Google ADK. Because of that, you can use my agent and create it like a Google agent. Okay. And after that point of time, we are doing ADK session. All of this is the normal ADK way of doing things, right? Now, same way we can do for Crew AI. You take my SDK, you create the Crew AI client using FloTorch Crew AI agent instead of just Crew AI agent, but it's a wrapper on Crew AI. Crew AI session, instead of just Crew AI session, it's a FloTorch Crew AI session. But post that, the way it operates is just like how Crew would operate. It creates a crew, it runs a crew, it does all the activities, right? Similarly for LangChain, similarly for LangGraph, AutoGen, and Stance. For now, these six agentic frameworks we have operating, and you can go natively in those and just use our SDK to do that instantiation, and the rest of it will work fine. And we are giving code examples for that here, as well as in that resources link. We are giving examples for each of them on how those will operate. Yeah. Yeah. I don't see any other open right now. AJ, any questions you see open?
No, Brijesh. I think I'm answering as many as I can, but you can look into the QA side. I see open 3 there. You can just look
Okay,
into.
yeah, I think this I've just answered. There's one open I can see from Haris. Haris is saying, if you ever explore bespoke multiple agent automation workflow operates real time, including continuous data ingestion, how does typically approach scoping and engagement like this? Okay, so what we are providing, right? Suppose look at from a customer perspective as now. Whatever I'm telling you, go to the host, try out things, etc. I'm talking to you from a pure builder perspective. Try out things. Okay. But suppose you're an organization and you want to operate with me, okay, and we want to set this up. So the way I'll set it up is depending on, like, suppose you're a finance organization, you don't want to be in this hosted environments, etc. You don't want your data to go out. I'll take my Dockers. I'll take this tool of mine, this gateway of mine, and make it available to you in your environment. After that, what's happening is, if you look at the logs, when the gateway comes into picture, what we have realized, what we have noticed, it is takes 1% latency, 1 to 2% latency is added on top of what would normally happen. So if you were going from here to OpenAI LLM and coming back, if you create an agent in your user space and then you're calling OpenAI and you're coming back, That, how much ever that was taking, we are adding around 1 millisecond on top of it to do the activity of routing it through the gateway. Okay, so that part is going to happen, but that part will give you an advantage where, as a company now, you will be setting up the agents. If you look at the webinar, which is the first webinar in this cycle, you'll see that those models that I'm talking about, you will set up the models, your GenAI architect will set up the models. They are the only ones who need to have access to these different environments. They are the only ones who need to have access to AWS and OpenAI. Rest of your developers don't need to have access to all that. They'll have access only to FloTorch. And the FloTorch model that they have access to will be well defined, will be decided by security and all those aspects. So if you're talking about speed, for example, then you will decide only these models are created, which are faster models, latency is less or whatever, right? Now, once you create those models and you're running it, right, you can run it, you can create a workflow in the FloTorch and then you invoke the workflow from wherever. The activity of running it, working it, and all is going to be essentially, you can say, transparent. FloTorch people may not even realize FloTorch is there, except that they've tried the SDK, like FloTorch SDK. But every call is going through the gateway. So what you are now able to get is latency. You're able to see the logs, you're able to see the traces, you're able to see where is it spending a lot of time. You're able to see how fast is it happening. You're able to see, okay, if I use this model from this zone, or if I use this model from this provider, which is faster. You're able to experiment and find out, is fast enough? What about accuracy? What about recall? Right? So what this tool gives you is kind of allows you to inventorize all your assets in one place, right? Either source it out or create agents and all of that, and then monitor it, observe over it, make it available that you give the flexibility to your developers to do everything, but also have control in them that whatever they do fundamentally is operating on these models only, so that you can have control on that. So these all allow you to be in a situation where you can create almost a hackathon like space in your company without losing sight of performance, compliance, and security, right? Because it's all centralized. At the end of the day, the gateway is there, and your team, your IT team, your security team, your GenAI team, they all can be rest assured, okay, you know what, we have control on it. We have control on the cost. We know what cost is happening. Okay, this model is going, we're going to remove that model. We're going to just shut it down, right? So nobody can use it. So those kind of things can happen in one centralized place rather than having to go to 10, 20 different places. That's the kind of advantage you can get. But if you reach out to us with specific requirements around that, our team is there. We can really, work out with you to put in place the solution in a way that is most beneficial for your organization. Runtime special runs. We are running on we are running on Docker, and there is some angle of Kubernetes on it. But and we are using some workflow. I don't exactly remember which one it is. I will have to check and get back to you, Abhishek. But we are going to make some refactoring there. We are not very happy with the necessarily with the Kubernetes way it's working, and so I think this. Christmas will be a refactor as usual. December is all about refactoring, so we'll probably be refactoring. But yes, that's the idea. It's an orchestration system we are using. We are not using one of the standard agentic ones. We are using orchestration systems which are the general old workflow agents. So we are taking each node to be agentic. So the nodes are running agentically, but inter-node we are using a workflow engine. Yeah.
Bridge, there is one question. The question
Yeah.
is the 1 million tokens that we talked about.
Yeah.
Is it including GCP, AWS, Azure altogether, or is it for one platform, 1
Yeah, 1
million?
million tokens. So basically what's happening is that 1 million tokens is like you're good. If you're using GCP, for example, it is your tokens being used up in LLM, right? Our cost for the subscription would have been the cost of the software, which would be normally accounted for technically for this thing is like we normally counted by tokens to show how much usage you're doing, right? So we are right now saying 1 million requests, which is around 1 billion token. That many requests you can use our solution for right now, because our intent is at the moment growth. Our intent is for people to try out and give us feedback so that we can make the product better. Right. So at this point, that 1 million tokens is anything, everything. It is not just GCP, OpenAI, anything, wherever you are using the keys. It may even be your own LLM. You may have an SLM working and you will running it on fireworks.ai. You can call it using OpenAI compatible. We have a one of the providers in model is OpenAI compatible. You can use that, and if your model is OpenAI compatible, you can call it. So you may create a model, host it on Fireworks, and call it, and that is also fine. But when that interaction happens, we know this many input tokens, this many output tokens, so we do a calculation and we say, okay, this many tokens have been utilized in this form. So that's how it is. But yeah, again, if you have any confusion around that, please reach out to me and I can explain it in with the actual thing. Yes, there will not be any vendor lock-in, Neil. I'll just speak your question first. Can you speak to vendor lock-in once I built all my agent model, etc. in FloTorch? Let's say next year I wish to move out of FloTorch. Is it safe to assume I would have to manually recreate everything in the new system? Would I still have access to the LLM systems on Google, AWS, etc.? Yes, so the two parts to the question. The wherever you're bringing your keys part, which is LLM, you may bring guardrails. You may have Amazon Bedrock guardrails you have created and you want to use it. You may create NVIDIA guardrails and you want to create it. Okay. You may have tools. You may have an MCP server set somewhere and you want to use it. Okay. So wherever you have something running somewhere and you're just pulling it in or you're just sourcing into our solution, they remain there. So it doesn't matter if you can even normally also you may be calling it from FloTorch. You can also call it from outside, right? You don't want to because then you're not monitoring it, but it's fine. You can do that. Now for things that you're creating in FloTorch, take an agent for example that you're creating in FloTorch, right? So for those at this point of time, yes, if you go out, it is not a tie-in. See, the code that you're writing is never going to tie you in. We are actually talking about we are trying a level best to be agnostic of everything, right? So which means that you could have a Amazon Bedrock model and you could have an NVIDIA guardrail, and in the FloTorch model you could have an Amazon Bedrock model and an OpenAI model and a Gemini model in the same LLM, in the same FloTorch model, and you could route past them. So all of these things can happen. But that advantage, that what the FloTorch model is having, the configuration of the model or the configuration of the agent today, you will have to recreate. Okay. But we are taking some steps on that also. Like I said, I'm creating blueprints, right? So blueprints at the end of the day is at the bottom is at the minimum, sorry, at the base is basically going to be a JSON schema, right? So what we can then operate even with the other vendors is that can I export a JSON and somebody else imports it, right? You may lose out some features. You may lose out the smart model feature, for example, because others don't replicate it. But the remaining part of it can probably be parsed out of that JSON schema. So it is early days. Right now, I'm focusing on getting some built-in schema blueprints. Towards the end of December, I will be giving you opportunity to save your blueprints. You can save your agent. You can save and export your agent. You can save and export your workflow. Then post that, I think the idea would be that we work with other vendors and see, okay, can we create a standard where we can just share our blueprints? Because our intention is not to lock anybody in. We feel that for an enterprise, there's enough value for using our tool that you don't need to have a lock-in activity. Yeah, I hope that helps, Neil. Thank you, Neil. Much appreciated, and thank you, Harris. Yeah, we will surely connect, Harris. Abhishek, yeah, I think we've spoken also. Yeah. Yes, I don't see any more on Q&A. Is there anything on chat?
No, Brajesh, I think I have answered all the questions on the chat side. Um, I have also posted our LinkedIn profiles links on the chat. So, guys, if you
Perfect.
have any questions or anything that you wanted to connect with us directly and then ask, we welcome on that as well. So you can simply send connections and we can have a chat over LinkedIn chat too. Thanks a
Yes,
lot for
and
all the good questions.
if you sign up, if you sign up on our environment, right, you will get a in addition to a verification mail, you will get a getting started mail. Okay, the getting started mail has got my ID on it. Okay, just write down a mail to me, and we can interact. Okay, if anything at all. Thank you, Chandra. I think Sunil, I'm not sure which one we're talking about. You've written one is pending, but I'm not able to see it behind. So yeah. I'm sorry if I missed something, but Sunil, you can just drop a line to us, okay, if we can, and we'll try to get back to you on that. Yeah. Do we have case studies for social media agentic AI agents? Um, Sunil, I don't think we have yet created a social media agent, but we will do it in December. So that resources I'm showing you, right? We have started with the fundamental building blocks in the beginning. Um, the idea was to give people an idea of how to use FloTorch, right? Because the SDK is there, etc. So we are teaching them on how to create LLMs, how to create workflows, how to create agentic, etc. But there is another part of it which we are showing where we are trying to create a insurance industry, finance industry. So in that space, in this coming months, we will surely be exploring social media. We'll be exploring. We are creating a FloTorch model itself, how a FloTorch agent can be instantiated in N8N, and many such things. So we'll keep everybody updated on this. We'll be more active now on our connecting points in the getting started mail. You'll see those points also. Like we'll be in LinkedIn, of course. We are also creating a Discord server. So yeah, we will surely be looking at that. But remember, resources is a public repo. I have purposefully kept it as a public repo so that if you come up, Sunil, if you or your team, come up with any solutioning where you're using FloTorch and you're coming with a solution, just send a PR to me. I'll just verify it for risk assessment from a perspective of an external PR coming in. But the intention is that you send me a PR and I will pull it in and pull it in your name, and it will be like your contribution to that sample repo, right? So that will surely be done. Yeah, my mail ID is there, but it's very simple. It's bridge, BRIJ, @flotorch.ai.